So today I want to teach you about socket programming, which is how you program networks at the lowest level. So if you are familiar with Linux and all the programming that goes into it, then you'll probably be familiar with the sockets API. But if you're someone who's coming from JavaScript or Python or anything, so if you've ever used like HTTP protocols by using fetch or anything similar, so what it really is that these HTTP and all these interfaces that you have available in these languages, they all always resort to these low level socket calls. So socket is basically the lowest level that you can program networking in. So all these HTTP requests, everything that happens through sockets. So today we're gonna dive deep into sockets and really see what is possible with them and really understand them to the deep levels. So I'll first minimize this. Yep. And then go here. So if you've ever like opened a TCP or UDP socket, you know how it goes is that you call socket and you call this AF inet, which basically means that this socket is going to be operating over the internet protocol. You can have something here like AF Bluetooth or something or app or Unix. Unix means that this communication by this socket is going to be happening on the local machine itself. The other socket where we are going to be sending data is going to be on this machine only. Bluetooth means that we're communicating over Bluetooth, and inet means we're communicating over the internet. So once we have fixed that this inet is there are like multiple protocols over the internet itself, like TCP, UDP, ICMP, IGMP, and there's like hundreds of them. So what we are really interested in, the interface that Linux provides us is mostly like TCP and UDP. So we program them by sock, DGRAM and sockstream. So up till now I thought like this is how it really works, and what really happens is that first I'll explain to you the concept of ports in internet. So giving you an example, that for example you're opening a website like youtube.com and it's trying to send you some video data so that you can play it on your device. So it's going to be really hectic if it only knows the IP address, your IP address, because it's going to send the IP, it is going to send the data to your IP address, but the all the applications that are open, they're also operating on your IP address. So to really distinguish between the applications, we try to assign them a port. So if I'm opening a socket, I'll assign a port to it so that YouTube knows that I'll send to this data, but also this port, so that the kernel knows internally that if any data or packet comes to this port, I'll just forward it to this application. So this is convenience, that I don't receive the application data of other applications, but also provide security that if I am currently using YouTube and Instagram is also running in parallel, if YouTube receives the Instagram packets, then that's a security concern. It's going to get all my private data. So the concept of ports really helps with that. So initially how it started, if you're ever done socket programming, is that you open this socket and you try to bind it to a particular address like this. Like for example, we open a socket over here and we bind it to a particular address that we give like this. For example, if we have binded this to port 8080 on this address. So if any packet comes on this particular address, the kernel will send the data to this particular application server.c, and I can receive it from this receive call. So I always thought that this is how it works. A socket always has a IP address and a port attached to it. But it's only recently when I stumbled upon the concept of raw sockets that I realized that sockets are not really related to any of this. Socket don't really need to have a particular IP or a port bound to them. And Another misconception that we commonly get from sockets is that socket is something that is getting opened on the hardware level, like it's an actual physical thing. Whenever I call socket, something is getting allocated on the hardware. So I want to clear this misconception that you have your Wi-Fi card on your motherboard somewhere, and the sockets are also operating somewhere. So are they connected or what? Like when I do a socket call, is there something getting allocated on the network card? So network card knows, okay, I'll use this particular thing to deliver YouTube packets, this particular thing on the network card to deliver Instagram packet. So it doesn't really work like that. It's more of the sort that network interface card doesn't really know anything. It's just receiving some Wi-Fi frames and it's sending those frames, and it doesn't really know anything about which applications are what. So who actually maintains these sockets? These sockets are actually just resources that are allocated by the kernel when a socket call is made. Whenever a socket call is made, the kernel just allocates some receive buffer, send buffer, and some control structures. And the nature of these structures depends actually on the type of socket that we are allocating. For example, I am allocating a TCP IP socket. So the kernel will have the receive send buffer, and along with that some information like which particular sequence number packet is going to arrive now, like all these stuff like flow control. If you really read about network programming, it maintains all those structures for the particular protocol. If the protocol is simpler, it will have lesser control structures. So socket is only a way for you to access your network interface card. It is not something that is there on the hardware level. It's not something that is actually allocated to a particular IP or a port number, which is how I thought it a little while ago. So all this is good terminology, but I recently got this assignment in my networks lab that we have to implement a kind of a DNS server, and we had to use raw sockets for it, so just so we can get a good understanding of it. And I want to show you like how exactly these sockets work and how exactly we can understand better how these networking protocols work. So over here, I'm going to create a client which is simply going to connect to this, and yep. So we're going to have the server address over here, and we're trying to connect to this. If you know the TCP sockets, this is how we work. Like we create a socket with sockstream, and then we try to connect to a particular remote server where we put the address in this structure. So we do this, and what I've done in the server is that I've not created like a normal TCP socket. I've created a raw socket over here. And to explain what a raw socket is, it's it can actually manipulate the headers at the transport layer. So transport layer is basically your TCP and UDP. All these protocols happen at the transport layer, and the headers for them are actually generated by the kernel. We only write the data to it using this send call. We write the data to it, and we don't really control anything related to it. We only write the data. But in raw socket, it allows you to actually control the headers of the transport layer protocol, and it can do much more than that. It can even control the headers till the link layer. But we're gonna see how exactly this TCP operates. So we've opened a raw socket over here, and after that we've set a socket operation. So what this socket operation really does is we are already manually including the TCP header. This socket operation is going to allow us to also include the IP header. So all these applications, they work like this is the IP header, then there is the transport layer header, then there is the main data of the application that we're trying to send. So when I opened a normal TCP socket, I only write this part. But when I opened a raw socket with TCP protocol, I'm going to write this part, and this part is going to be generated by the kernel. Now that I have set the socket operation to include the IP header as well, I'm going to be sending all this, and kernel will only include the link layer header. And for further, what I'm doing is I'm just trying to see what actually happens when the other party sends me an accept call. So I'm just binding it to a particular address, which is 127 on port 8080. Again, I told you that the socket don't really need to be bound to an IP and a port, which is true, but this is more just to test how this IP TCP accept call works. So I've bound this to an address, and in the client I'm trying to send the data to this address only. And here I am doing the receive call, and the buffer here will now contain the IP header, the transport header, and the actual data that I'm sending. So in the client application I'm only sending the data. Like in the connect call, the I don't really know what really happens in the connect call. We probably don't really send any data in it. We only send like some header information that we're trying to synchronize right now. But anyway, we'll see right now. So I wrote a make file for this, so I'll just make and run the server. One other thing is, to operate raw sockets you need root level access, because again told that raw sockets can be used to access the network interface card without needing to operate on a port or anything. And I earlier explained the security concerns when you don't really have a port, that if I don't have a port there, all applications can access the other applications packets. So that's a vulnerability, that YouTube can access Instagram's packets. So raw sockets can do that. So we need a root level access for this. And the server is started. Now when I start the client, this is where we see the connect. Obviously I didn't really send a response back, but what really happened is that I got a IP header first and then a TCP header. So when the client application tries to call connect, I can see that the TCP header contains this SYN flag, which is basically the synchronization flag. So accept call is basically telling to start synchronization so that we can further connect and everything. And you can see that the destination port is 8080, which is where the server is operating. So the client send this packet to the server to this particular destination port. You can see the IP and everything. Protocol is 6, which means TCP, and this is automatically sent by the kernel. I didn't really send it in my application. It seems to be an automated behavior by the TCP protocol, I guess. But this is just to show how you can use raw sockets. But the assignment that we were actually given was to implement a DNS server, which was quite something. So where is this? Yes, so what we were trying to do is that the client application will request to have its domain name resolved. Like client application will request google.com, and we're supposed to send back the actual IP. So it's better just to show it. So first run the server. And then we can run the client. So you can see that request actually had these domains: google.com, facebook.com, instagram.com, and after that the application got this particular IP address for this. So we can open it and it will lead to google.com. So yeah, so this is the main particular thing of this application. Just send back the actual IP address for that domain. So how did we achieve this? So in this DNS server, what we're doing is we're opening a raw socket, and I want to make one point clear is that this is not actually how DNS servers are actually working. There is a separate way, like they they usually operate over UDP only. They're not really like a separate protocol. We were just supposed to invent our own protocol to handle DNS lookups. So this is not really how practically DNS works. This is just to understand the raw socket thing. So here we are actually just making a raw socket over a protocol, this SDNS, which is not really implemented by the kernel. So what doing this protocol does is that socraw over inet is responsible for actually pulling out all the IP packets which have the protocol number matching this. So in the previous one I saw, I there is this IP header and it contains this field called protocol. So when a packet arrives, what kernel does is that it checks this protocol and it tries to check all the sockets which are opened over this particular protocol and tries to look further that if these sockets actually need to have these packets sent into the receive buffer. So here what SDNS does is that when the client actually sends a packet which has this particular field setup, like in the IP header, I send the protocol as IP proto SDNS. So when this packet arrives, the kernel automatically will pass this packet to my socket, which I have opened here. And then further, what we're really doing is just some bit manipulation to send the actual IP address back to the client. Yeah, this was actually like really cool. Yep.